Welcome. Today we're diving deep into James Watt. The man whose name is quite literally the measure of power, the watt.
Exactly. And we're aiming to explore not just his famous inventions, but really the whole journey. How did he get there? What specific problems was he solving? And what can his story teach us today about innovation? And maybe perseverance, too.
Let's kick off with his beginnings. He was born way back in 1736 up in Greenock, Scotland.
Right. And interestingly, he didn't have a typical formal schooling at first. His mother, who was well-educated, taught him at home initially.
And the sources say he had this real aptitude for mathematics, right? Like,
Right.
apparently he wasn't so keen on Latin and Greek.
No, definitely not. It's also worth mentioning he struggled with poor health his whole life, constant headaches, things like that, which makes his later focus even more remarkable, I think.
Yeah, definitely. So what was the turning point that set him on his path?
Well, his father's business ran into trouble, so Watt needed to find work. He ended up going back to Glasgow, and that's where he landed a really crucial opportunity, which repairing astronomical instruments for the University of Glasgow. Think about the precision needed for that.
Ah, okay. So not massive engines yet, but very fine, detailed mechanical work.
Exactly. And this wasn't just a job. It plugged him right into the university network. They actually gave him space for a workshop there in 1757.
And that's where he met people like Joseph Black, the chemist and physicist,
Oh,
and Adam Smith.
that's right. Hugely influential figures. This meant he wasn't just a practical mechanic. He was mixing with thinkers, getting grounded in the scientific principles of the day, like Black's work on latent heat.
Which leads us neatly into the big problem he tackled, the Newcomen's steam engine. It was used everywhere, mostly for pumping water out of mines, but it wasn't very good, was it?
Not really, no. It was incredibly inefficient. Watt was asked to repair a model version for the university, and that's when he really dug into why it was so wasteful.
And what did he find? What was the core issue?
It was all about heat loss. Massive heat loss. The Newcomen engine worked by filling a cylinder with steam, then injecting cold water into that same cylinder to condense the steam and create a vacuum.
Okay.
But that meant the cylinder itself got cold. So for the very next stroke, you had to pump in a huge amount of steam just to heat the metal back up again before it could even start doing useful work.
Right, so most of the energy was just reheating the container, essentially.
Precisely. Watt figured out something like 3/4, maybe more, of the thermal energy was just wasted on this constant heating and cooling cycle. It was fundamentally inefficient because of that step.
So faced with this huge waste, what was his breakthrough? This was around 1765, wasn't it?
Yes. His brilliant insight was the separate condenser. Instead of cooling the main cylinder, he devised a way to draw the steam off into a separate vessel to be condensed.
Ah, so the main cylinder could stay hot all the time.
Exactly. He even added a steam jacket around it to help maintain the temperature. This simple change, conceptually simple anyway, just drastically improved the engine's power and efficiency. It cut fuel costs massively.
It basically transformed it from, what, a machine of marginal efficiency, as one source put it?
Into the absolute workhorse of the Industrial Revolution.
Yeah.
But having the idea is one thing. Making it a commercial success is another.
And Watt himself wasn't really cut out for business, was he? I read he called himself a poor businessman.
That's putting it mildly. There's that great quote where he says he'd rather face a loaded cannon than settle an account. He hated the financial side.
So he needed help.
Desperately. And he found it in Matthew Boulton. They formed a partnership in 1775. Boulton wasn't just funding. He had the business sense, the factory, the connections.
And access to better manufacturing techniques, right? Like Wilkinson's precision boring method.
Absolutely crucial. Watt's design needed much tighter tolerances than the old Newcomen engines to prevent leaks. Wilkinson could make cylinders that were accurate enough. That partnership was absolutely key to getting the engine produced and sold effectively.
And Watt didn't just stop there, did he? He kept innovating.
Constantly. Driven by need or sometimes by patents held by others, like the sun and planet gear system.
Right, that was to get around a patent on the crank mechanism for rotary motion.
Exactly. And then there was the centrifugal governor in 1788, which was huge for factories.
Oh, so?
It automatically regulated the engine speed. Suddenly you had a power source that was stable enough to run complex machinery reliably.
Yeah.
A massive step.
And he was apparently proudest of his parallel motion linkage.
Yes. An elegant bit of mechanical engineering that allowed the piston rod to push and pull, enabling double-acting engines. More power, more efficiency again.
It wasn't all engines either. He invented that letter copying press, too, which was commercially successful in its own right.
Yeah, patented in 1780. It shows the breadth of his inventive mind. The chemist Humphrey Davy summed him up well, talking about his profound knowledge and his ability to apply science practically.
And that focus comes through in that quote associated with him, the one on the 50-pound note. I can think of nothing else but this machine.
Captures that relentless drive, doesn't it?
So thinking about what we can take away from Watt's story today,
Hmm.
what would you say are the key lessons for you listening?
Well, first, the importance of really understanding the fundamentals. Watt tackled the physics first. Second, know your weaknesses and find partners to fill those gaps like Boulton did for Watt's business aversion.
And third.
Relentless iteration.
Yeah.
Keep refining, keep improving. Even the small details matter.
So a final thought to leave everyone with.
Watt's big breakthrough came from identifying and fixing a massive source of waste that wasted latent heat. So the question for you is, what processes or systems around us today are stuck in a kind of primitive state of efficiency? Where's the massive waste hiding in plain sight, just waiting for its own separate condenser moment?
A great challenge to consider. Thanks for that deep dive.